Hi guys, welcome back to our channel. So today I took a data set from Kaggle. The data set is automobile insurance claim prediction. So here the objective is to make the prediction. The claim is fraudulent or not. So it's a binary classification problem. So as usual at the beginning we just import the libraries. So I'm importing pandas, importing numpy, and we want to filter warnings. So importing warnings and filtering, and then importing Seaborn and Matplotlib for data visualization. And if you don't have the basics of Seaborn and Matplotlib, so you just refer our videos in the channel. And then we are setting the options properties display dot maximum columns to 50 and maximum rows to 100. So these libraries are imported. And then this is my file insurance claim.csv file. So reading the CSV file and creating a data frame and then displaying the header part of it. So these are the first 5 rows. So in the months as customer, age is there, policy number is there, policy bind date, policy state, and some other important attributes are policy deductible, annual premium, then insurance zip, the gender, male, female here, and insurance insured education level, or the degree, and then insured occupation, then hobbies. So finally our main objective is to know whether the claim is fraudulent or not. So this is our target variable, fraudulent, fraud reported. This has two unique values, y and n. So y means yes, n means no. So this is the display of the data, and then I'm just checking the shape. So data frame dot shape. So this gives us the number of rows and number of columns. So we have 1000 rows here and the number of columns are 39. And then getting the info method will display what are the columns importantly and what are their data types. So as you can see, totally we have 39 columns, and you can check out the data types. And at the last it also displays the number of columns in different data types. Like we have one column which is float 64-bit type, and 17 columns which are of integer 64-bit, and there are 21 columns which are object type. As you know, no machine learning algorithms works with object type of data, so we have to convert these 21 columns into numeric, and the total memory consumption is 304.8 plus kilobytes. So after this I want to check the missing values. So we can do that by using the method isNA, so which returns true or false, and then we are summing up. So how many missing values are there, or column wise. You see no missing values here, right? No missing values, so all are 0, but there are missing values. We'll check that. And then we are applying value count on the target variable fraud reported. On the same, we are also plotting a count plot. So sns dot count plot of, we are showing the fraudulent fraud reported, which has two unique values, s or no. The data is df, means data frame. So we are printing the unique values, where the frequency of n is 753, frequency of y 247. Okay, s type is 247 and no type is 753. And for the same we are plotting a count plot. So count plot gives the frequency or count on the y-axis, and x-axis we are showing the values. So no is more, so no is 753 and s is only 247. So with this we can say it is imbalanced data. Understand, the data set is imbalanced, means the majority of the samples are classified into n. The count of y is less here. So with this kind of data, if you build a machine learning model, it mostly classify the samples to n type, because it has learned more with n. The number of samples in y are less, so it is a imbalanced data. So we have to make the data balanced, and then if you build a model, then that is going to be very fruitful. The accuracy of the model is good. If you build a model with not balanced data, then it may give you the negative classifications, right? So that's why we need to balance the data. Next, I'm checking the column, this df dot incident state dot value count. So we are doing EDA, so exploratory data analysis. So whenever you are given with the data set, you need to perform the methods like univariate analysis, means exploring single variable and try to understand the trained data. Bivariate analysis means comparing two variables, and multivariate analysis comparing more than two variables. So you have to perform this. So before you build a model, you have to determine the target variable is depending on which other variables. So what is the effect of the variables on a target variable? So based on what factors you can make a decision, the claim is fraudulent or no. So you have to find the importance of the features. So what we are doing is here, next, checking the count plot of incident states. So these are the various states. NY stands for New York. These are the other states, and the majority of the claims are from the state NY. The next highest is SC. Next highest is WV, like this. And on the same, we are plotting the count plot with respect to fraud reported. So which state has more fraudulent activities and which state has less fraudulent activities? As you can see here, orange color means no, so no fraudulent or more in New York. And what about the fraudulence? S type is more in the state SC. So this is the comparison between the variables. So what we are doing is a bivariate analysis. So checking the relationship between the incident state and fraud reported. Next, I would like to see the other variables. So here I took the policy state. So count plot on x-axis policy state, and y-axis you are showing the count compared with the target variable fraud reported. So which policy state has more fraudulent activities? So that is this OH. No is more also in, I think that could be this IL. So this is a count plot. Next, having a count plot between incidence type with the target variable. So specifying the figure size here, or 10, 5, and you can see incidence type. So a majority of the samples, right? Majority of the samples, S type is higher, in which state my multi-vehicle collisions, and no is more. No is more in multi-vehicle collisions. So parked car, if the car vehicle is parked, the number of incidents are also less. You can see here. If the vehicle is theft, then of the fraudulent activities are less, even non-fraudulent is also less when you compare with other categories here. Next, understanding the variables, I took the incidence ensued checks, means gender. So on this gender, applying a pie chart, plt dot pie chart of, this is a percentage. So we want to have 2 decimal digits, and the labels are male and female. So this particular column has 2 unique values, male and female. So we want to display them. So that's why specifying the list of labels, and the font size for this is 12, and the title of the figure is this one, gender percentage. And y-axis label, we are specifying nothing, means empty, then plt dot show. So this shows the pie chart, and with this, you can see ensure male percentage is more, 53.770, compared with the female percentage. Female percentage is 46.30. So most of the people are male than female. So this is univariate analysis. Then similarly, having a one more pie chart, So specifying the figure size 10,6, then accessing the column institute relationships, getting the value count multiplied by 100 divided by length of data frame. So this is going to give us the percentage. On this we are plotting a pie chart. This is the formatting for percentage, how many digits, so one floating point digit, and this particular institute relationship has the values like husband, wife, own child, unmarried, other relative, not in family. So these are the unique values for the column institute relationship, specifying the font size for that, and relationship percentage is the title of the figure. Then y-axis label is not there, and this is the pie chart. So highest values, this 18.3%. So relationship is a husband, and the frequency of that is 18.3%. So this is the simple pie chart. Then just displaying the data frame again, and from here this one, df dot policy report available, the policy report is available or not. So what is the count for that? So it has the values like question mark, and then no, S, report is available or not. S type is 314, no is 343. And when we check the missing values, so that time we got the count for missing value 0, right? But you can see question mark. So what is the meaning of that? So question mark means unknown. We can consider as unknown, not mentioned or not entered. So it's a missing data. Again, manually we are checking property damage dot value count. So here also you can see unknown values 360. Then collision type, checking the value count. So here also you have the question mark, the frequency is 178. So what we are trying to do is we just consider this question mark as missing value. So it is not recognized. As we check the missing values count, we got 0. So means this question mark is not treated as a missing value. So that is why in the complete data frame, so df dot replace question mark np dot nen. If there is a question mark, then consider that as numpys nan, means missing value. Nan stands for not a number. So in place is equals to true, means it will have an effect. Then after doing this, I'm checking the missing values. So these values are having 0, but in case of these three columns like collision type, we have 178. Then the count for property damage is 360, and the number of missing values in policy report available is 343. So these are the missing values. So our next immediate step is to do the imputation. So imputation means you can fill the missing values with the mean or median or mode. If you don't have any knowledge on this, you can refer our video, so how to do the imputation. So there is a video on this. So df dot policy report available is equals to df dot policy report available, and it is no, it is a object type. So that's why if the column is object types, we have only one option, that is you have to impute with the mode. So applying, replacing with the mode. Similarly, property damage is also object type, so filling with the mode. And then collision type is also object type, so filling with mode. So this imputation is done, and after these three steps, checking the number of missing values. So we don't have missing values, so the count is 0 0, means no missing values. So once we have done that, I'm applying the label encoder. As we saw, there are columns 21 which are no object types. So we have to encode them. Got it? We have to encode them into numeric. So importing label encoder. So even if you don't have the knowledge on encoding, so you can refer our video. So there is a video on this encoding methods. So label encoder is the one which simply convert the string type of data or object type of data into numeric. Like for example, insert sex is there, means male. We have female, male and female or the unique values. So what it does is it assigns 0 to female in alphabetical order and 1 to male. Similarly, it depends on the number of unique values. It's going to give the numbers like 0, 1, 2, 3, 4. And then policy state, also applying label encoder on insert education level, insert occupation, insert hobbies, insert relationships, collision type, incident severity, and authorities contacted. So on this we are applying the label encoder. The method is fit underscore transform. That means fit the data and then transform, and the result is assigned to the same column. So we are not going to create any new column on the same column. And then also incident state, incident city, incident location. So all these columns are converted into numeric. And then, sorry, I think I didn't run this, so let me run that and then again run this cell. So it is done. You can check the header part of the data. So head of 3 means displaying first 3 rows. So you can check no column, no columns value is string type or object type. So all are numeric. Understand? All are numeric. So then we can go for building a machine learning model. Before that, we have to find the feature importance. So which features are important? So which features can affect the target variable? So for that, we can do the correlation. And in the next step, I'm plotting a heat map. So importing matplotlib, I think we have already imported it, so no need to import multiple times. And then specifying the figure size here, 20 by 15, and then plotting a heat map. So SNS dot heat map of what is data. Data is on the data frame, correlation is applied, and annotation true means the correlation value can also be displayed on the graph. The formatting is this, line width is 1, and then plt dot show. So it shows the correlation between the variables. As there are 39 variables, so it takes time, not much, but it takes time. So heat map is nothing but it's a color representation of the correlation value, numeric value. So this is a color plot. So if it is if the color is black means negative correlation. If the color is this, then strong correlation. So as there are many attributes, so we cannot see the graph properly. So that is why in the next step I'm performing the correlation and then sorting the columns in descending order. So correlation is equals to df dot correlation, and this is the target variable, and filtering here correlation greater than 0.001, and the index of that is assigned to the columns, and then correlation filter based on the columns, and sorting the values, sort values ascending false means in descending order, it means in decreasing order. So you can see the target variable is having 1.0 means 100% own compared with other. So which column is having higher correlation value? So you can check out 0. Yep, this one also. So as we are doing in descending order, so vehicle claim, total claim amount, property claim, insured injury claim, umbrella limit, like so these are the correlation values. So we can consider these columns as important, and you can build a model with these important attributes. So just getting the columns, and then not to copy these in the next. So we are displaying the column, so getting the list of columns. So featured columns, these are the featured columns. So we are getting the list of important columns, then the feature variable is created, and then we are doing data separation, separating the data. So in X we are putting all these variables. In Y means target variable, so X and Y are decided. So once X and Y are decided, you can go for building a model. So before that, we are splitting the data. So importing train test split from scikit-learn model selection, then splitting x and y into 70% and 30%. So train size is uh, 70% because you mentioned the test size was 0.3. 30% is um, test size, 70% is train size. So no value is fixed here. So machine learning is just trial and error. So if you are getting good results with this separation, then you can stick with this value, or you can also divide your data into 50-50, 50% training, 50% testing, or you can split the data into um, 60-40, 70-30, 80-20, 90-10. So random state we mentioned 42, then the data separation is done. And as we have already seen, this data is imbalanced data, so that is why I'm using one of the technique, oversampling technique, that is smooth importing smooth from imbalanced imb learn dot oversampling. And then this one is already done, so no need to do this multiple times. Then splitting the data into splitting x and y, random state is 1, stratify based on the target variable, then they are done. Then checking the value count for the label. You see uh, before applying, right? This is before applying. So 0 is 565 and 1 is 185. So it is imbalanced data. Now we are applying a smooth. So creating object to the smooth class, and then this empty dot fit sample, fit resample x train y train, and then it will give us the binary counts. Now you have equal number of rows, equal number of rows, or equal number of rows into x and y. That means equal number of samples. If I have 65, 565, so 50-50 equal distribution is done here. And then uh, I'm applying a set of set of algorithms. So importing the required algorithm from the respective model, from respect to modules. So importing XZB classifier from XZBoost, importing model selection from sklearn, and importing logistic regression with CV. CV stands for crash validation. Importing decision tree, neighbors classifier, random forest, stacking classifier, crash validation score, imported from scikit-learn model selection. And this one repeated stratified k-fold. uh, it depends on you may also improve your results, right, by building multiple models. And here I'm applying ensembling. I'm supporting ensembling. So once these are important, then the method is defined, get stacking. So stacking is one of the ensembling method. So creating a list. So list 0 equals to list. This is empty list. Then to the list we are applying first algorithm, is DT. So this is a name, and this is the algorithm, decision tree classifier. So my first model is decision tree classifier, and I'm also doing the parameter tuning. So maximum depth of the tree is 10, the random state mentioned 5. And then second model is random forest classifier. Number of estimators 500, means the number of decision trees are 500. Then also applying k neighbors classifier with k value as 5. Then also applying XZBoost classifier. The parameters are object2 is a binary logistic, means we have only two unique values, s no y n. And then so this is at the level 0. These models are built. On top of this we are applying the logistic regression. L1 level 1 is equals to logistic regression. And then we are applying stacking. On all this we are performing stacking. So stacking gives the results. So if you don't have the basics of stacking, you can refer our videos. What is ensembling, what are the different types of ensembling, and each ensembling type which algorithm falls. So for that you can also refer our video. So stacking classifier at level 0, this is level 0. On top of this, level 1 CV means crash validation, tenfold crash validation. Then this is going to return as the model. And this is also another method, get models. What are the models? So models equals to dictionary, then decision tree, random forest, KNN, XCB, stacking. I was working on different models, so uh, develop these two methods. So either you can use this or this, right? So you can check the number of algorithm used here, and the drawback of ensembling is the model building time. So as we are building multiple models, so it may take time. So XZB classifier is done, then on that stacking is done. Then we are calling the model. Which model? This one, models equals to get model, means these algorithms are applied. Then how to evaluate your model? So for that also we are defining a um, method, evaluate models. It is taking three parameters, model x, y, cv equals to repeated, stratified, fold. The number of fold is 10. Repetitions, how many times? 3 times. Random state we mentioned 5. And then getting the score of each model. So score equals to crash validation score of the model, and the scoring is using accuracy. We are checking the accuracy. Crash validation we mentioned is of tenfold. Number of jobs -1 means all the cores of the processor are used, all the cores of your system are used. Then error score raise, and then when you call this method, it will give the score of individual model. Then creating empty list here, results, names. So these two are empty. Then for name and model from models.item, so you're getting the score. So calling the above method, evaluate model, 3 parameters, appending the score to the results. And then names.append of name. So name is also added. Names means labels of the algorithm is also appended to the names, and then displaying the name. What is the algorithm? What is the mean square and the standard deviation square? So now we are running this, so it will take time because we have to develop these models, so it takes time. So still it is running. You can see the kernel is busy. You can see the output here. Decision tree, the accuracy is 69.69 is the average accuracy. A deviation is, standard deviation is 0.05. The first model is decision tree. So have a patience because it takes time. So you can see here the performance of these models are decision tree 69%, random forest 78%, KNN 66, XZB, XZBoost classifier 77%, and stacking is 79%. So the highest performance is with stacking. So with these performances, I'm plotting a graph. So box plot, plt dot box plot on the results. Labels are names, and show means true, means these are the mean values. Then plt dot show. So this shows the performance of these models. So stacking has gave the highest performance, right? And the XZBoost is 77% XZBoost. So these are the 5 models we have developed, and you can save the performance of these models. So importing pickle, then pickle.dump, dumping the model, and you are saving with this name in the mode write and binary. So this is how you can build a model, and you can make the prediction for your data set. So the objective was here to build a machine learning model for automobile insurance claim prediction.